Hi, this is fourth part of the video of the 2K Factorial Design. The problem we are going to solve is an engineer interested into effect of concentration of the reactant and the amount of catalyst. These two are the factors on the conversion yield. This is the response variable in a chemical process. So the two levels of the reactant concentration are 15 and 25. Whereas the catalyst B named as factor B, the high level is termed as 2 pounds and the low level is 1 pound. The experimentation has been replicated thrice, so there are total 3 multiplied by 4 equal to 12 runs, where 3 are replication and 4 are the number of treatments in each replication. The order in which the runs are made is random. It means that the chances of the biasness in the experimental results has been minimized. So design is completely randomized design. These are the observations. When both A and B are at low level, we got 28 in the first replication, 25 and 27 in the second and third replication respectively. Likewise, this is the data. Plus sign both and A and B at high level, we got 31, 30 and 29 in the third replication. So we can take the sum of them. These total will be used in the manual calculation while we are using the formulas. However, if you want to solve this problem using Design Expert or Minitab, so you will have to this individual data of the replications. Please do not use this sum, because if you ever use this sum values in the Minitab, for it will means that we have only performed one replication and there will be no degree of freedom left for the sum of square of the error. So it means we can't calculate the mean square of error when we have used these values in the Minitab. So this is the graphical representation when both A and B at low level. So this corner its sum is 80. Effect of A, when A is at high level, we got these three values and the sum is 100. Now we are going to use all these values in the formulas. To calculate the effect of A, I have written the formula. So we have 2n is equal to 3, AB is equal to 90. I got this value from there. Then A, in place of A I have written 100, you can see. Then B is equal to 60 there, and 1 is 80, you can see it there. After putting all of the values, we got 8.33, and this is the effect of A. If we want to use this value further, we can use this value and we divide by 2. So 8.33 divided by 2, we got 4.167. This value is the slope for this factor A, or you can say it is the slope of x1. That is the concentration of the reactant. So we can see that the concentration of reactant is positive. When we increase it, the concentration of the reactant over yield increases. So the positive result suggests that increasing A from low level 15% to high level 25% will result in the increase of yield. Now in order to calculate the effect of B, let me write the formula. So AB, again I have picked the same values. AB is the 90, B 60, you can see the B is 60, A as 100, A is 100, and this one is there 80. So all of the values have been put there, sorry. And then 3 is the number of replication I have told you in the previous page. Upon calculation, we got the effect of B as -5. When we divide this -5 by 2, we got beta 2 is equal to -2.5. This is the regression coefficient, or you can say slope of the variable x2, where x2 is the catalyst. The negative sign suggests that increasing the amount of catalyst added to the process will decrease the yield. Here are all of the three formulas for calculating the effect of A, B and AB are mentioned.